This lesson deals with Supplemental Problem 3.5. You can find this problem in the course ebook in the Chapter 3 Supplemental Problems on page 8. Let's find the current I2 in Supplemental Problem 3.4 by using superposition. Recall there were 4 sources in the previous problem. There was a 10-volt source here, a 6-volt source here, and a 5-amp source here. Let's set those equal to 0. I'm going to find I2 due to this 1-amp source. So I'll short the 2 batteries, open the current source. And this current I'll call I2 prime because it's the value of I2 due to my first source. That current is flowing in here and creating a drop of 2 ohms times I2 prime, but that same current is also flowing through the 1 ohm resistor because of the open circuit. It's going to be 1 times I2 prime. Let's go around the loop. Got a drop in voltage of 1 times I2 prime, another drop of 2 times I2 prime, but no rise in voltage, just equal to 0. That means that 3 I2 prime is equal to 0, and therefore I2 prime is equal to 0. In fact, what we've done is shorted out the circuit by having these 2 short circuits here. Many times doing superposition, you get a lot of really simple answers and quicker to find the overall answer. Next, we're going to set the 1 amp equal to 0 and short the 10 volts and the 6 volt. Find I2 due to this 5 amp source. Call this I2 double prime due to my second source. Now, these 3 elements are all in parallel with each other, the 1 ohm, the 2 ohm, and the 5 amps. I could use current divider. I use the resistive current divider, which says if I want the current in the 2 ohm resistor, I'll take the other resistor over the sum of the 2 times the current source. This is going to be 1/3 of 5, which is 1.666 amps. Now I'll set the 2 current sources equal to 0 and the 6 volt equal to 0 and find the current due to this third source, the 10 volt. Because of the short circuit, I've got these elements in series with each other. And so the current is going to be just the voltage divided by the total resistance. And I'll call that I2 triple prime. 10 divided by 3 would be the value of I2 triple prime. And that's 3.33 amps. Lastly, we'll do the 6 volt source, where we're going to set the 10 volt source, the 1 amp, and the 5 amp equal to 0. So here's where our 10 volt source was, and here's where our 2 current sources were. We're going to short the voltage source and open the 2 current sources. Call this I2 quadruple prime to be the current flowing in the 1 and the 2 ohm resistor. Now the voltage across these 2 resistors is a minus 6 volts. Dividing that by 3 ohms, we get a minus 2 amps. And add our 4 results together. We get 0, 1.66, 3.33, and minus 2. Add all up together, you get 3 amps. This is the same result we had in Supplemental Problem 3.4 and also 3.2. And this is Supplemental Problem 3.5.